AP, let's get started with Chapter 2. This chapter is going to talk about atoms, molecules, and ions. And while it is true that there may not be very many questions on the AP exam that assess this information directly, that is true. However, this type of information is going to be the information that you use to critically assess the questions that are on the AP exam. There are going to be lots of fundamental points of information that you're going to be expected to have that you use to figure out questions on the AP exam. So again, while there aren't necessarily going to be a lot of questions about these exact things on the AP exam, this is still fairly critical. Just a little background here. This coin right here is actually the prize, right? It's the physical representation of the highest honor given by the American Chemical Society. This is a picture of Joseph Priestley. He's actually an Englishman. He knew Benjamin Franklin. Benjamin Franklin actually got him into a couple of different things. But Joseph Priestley died in 1804, living in the United States after he was forced out of England due to some political blowback. The other side of the coin is dedicated to Linus Pauling. Those of you who have already taken Chem, hopefully you remember that name Pauling. The Pauling scale is an arbitrary scale used to record electronegativity values. But yeah, just if you guys ever see this is the biggest deal that a chemist can receive, short of the Nobel Prize in chemistry. Anywho, so a quick history of chemistry. Now again, this is going to be almost a little bit of a history of a science, which is true, which is fine, but we're going to see how general science has moved into what we today consider to be chemistry. So let's go all the way back to 1000 BC. Around this time, weapons were the be-all, end-all. The Iron Age, the Stone Age, the Bronze Age, things like that. With the exception of the Stone Age, all of those metals are taken from ores. Now, an ore is something that you simply take out of the ground. The raw thing that you dig up out of the ground. There are going to be metals in it. There are going to be rocks in it. There's going to be dirt in it. But there was a process that was developed to physically separate the useful metals from what they didn't want, the rocks and the dirt, right? And so that process had to be thought up. It had to be practiced. It had to be tested, right? And so that was a systematic inquiry, which is science. That's what science is. It's a systematic inquiry. Also around this time, embalming fluids being widely used, and not in every culture, but in several cultures, they certainly were, and they were becoming more and more popular at this time, even if they were only used among the more affluent members of the society. Fast forward to 400 BC, the Greeks came up with this idea that all matter was made up of only 4 elements. You guys have heard of these: fire, earth, water, and air. And this is how they viewed the universe. This is the model that of the world that they held. Now, you guys remember what it means to be a model? You take data that you have already taken in, and you use that data to predict other things that you should observe in the world. And the Greeks did that, right? Because they knew what science was. And while this system of having 4 elements was able to predict a lot of what they saw around them, it's true. They actually successfully predicted quite a bit of stuff in the natural world, but there were still some inconsistencies. And so what that made them think, the Greeks at this time, is that not that their system was totally bonkers. It was simply that they were missing one element. Instead of 4 elements, they thought that actually some 5th element was missing. And the idea of the 5th element has started at this time and has moved through various cultures to the present day. In fact, just a few years, I guess it's getting several years ago now, There's a Bruce Willis movie called The Fifth Element, right? And that was the thing that was going to change the world, understanding what the fifth element is. And that's what the Greeks thought that this fifth element was. If they were to be able to identify what this fifth unknown element was, that their understanding of the natural world would really become tight, really be locked in. They'd be able to predict and understand the world around them. And different people thought that fifth element was different things. For example, in that Bruce Willis movie, the point of the movie was that the fifth element, the thing that makes the world go around, is love. Right? That's probably not what the Greeks were looking for. But this was a real system that was in place around this time in the more sciencey and more philosophical areas of the ancient world. For example, even if you read something as new as Meditations of Marcus Aurelius, one of the golden emperors of the Roman Empire, he mentions the dissolutions of the elements, and he mentions fire, earth, water, and air, and how matter simply will change back and forth between these four fundamental states. But between this time and when we pick it back up in the 16th century, which is about 2,000-ish years, alchemy ruled the day. You guys have heard of alchemy? You've heard of transmutation, probably. Alchemy is a pseudoscience. Now, pseudo means fake, right? It means not true science. And a lot of people think that this is a very, very negative thing to say. And some people intend it to be very, very, very negative. For example, people will use the term pseudoscience to mean it's not useful. And while I do use the term pseudoscience regularly, I don't view it quite as negatively as other people do. For example, the classic pseudoscience that people refer to is psychology. Now, it's true, it is 100% a pseudoscience, but that does not mean that it's not useful. The reason that it's a fake science is because science is a systematic inquiry, and it centers around the ability to control all variables at play. And when you come to an area of study like philosophy or like sociology, for example, you're studying the human animal, and you're also studying the group, right? The human animal in the type of group that they inhabit. And those two things, the group and the human animal itself, are far too complex. It is absolutely impossible to control all of the variables in that type of science. Therefore, it is a pseudoscience. It doesn't mean that either of those studies are not useful. It's just not an empirical science in the same way that like a physics would be, or chemistry, or even a biology. To continue that point, alchemy, while it was a pseudoscience and it's not really practiced anymore, doesn't mean that things weren't learned. It doesn't mean that it wasn't useful. A lot of stuff was learned from all of the mistakes that alchemists made throughout their time when they were at the top of the science world. And in fact, that's where you learn most of the stuff in science, is when you mess up. Now, in lab, in high school class, you just want to get it right. I understand that. But when you're actually on the front lines of science, the most interesting things happen when you make mistakes. Let's get up to the 16th century. We have a continuation of systematic inquiry. George Bauer, a German, continued to refine the process of extracting metals from ores. Right? Same thing that was happening up here, because, let's be honest, weapons still make the world go round. Paracelsus, and I'm sorry, I'm not Swiss, so I might be butchering that name, is noted, or at least recorded, as the first person to use minerals for medicinal applications, as opposed to leeching, bleeding, calling in good spirits and casting out bad spirits. This was the first time where someone used human methods to try to increase someone's medical station. Then we get into what we would actually consider to be chemistry. Robert Boyle, he's an Englishman, largely considered to be the first chemist, because he was the first person to perform quantitative experiments, right, with numbers. where he measured masses, he measured densities, he measured volumes, he measured this, he measured that. He controlled aspects of the experiment, and so that made him the first empirical scientist who did this type of work. So we call him the first chemist. Then move forward to the 17th and 18th century. George Stahl, also a German, suggested that something called phlogiston flowed out of burning material. And so you'd burn like a piece of wood, and that's not necessarily smoke that comes out. It's a substance that's called phlogiston. And if you put a burning object in a closed container, it would go out because the air around the burning object would become saturated with phlogiston. And if there wasn't any more room for phlogiston to come into that area, the combustion would stop. Now, this is an example of a mistake. That's not true, right? We know that oxygen is required for combustion, right? And oxygen doesn't. It's not as though phlogiston actually is oxygen. He just called it a weird thing. This is kind of the backwards idea. Phlogiston is a substance that flowed out of burning materials. Oxygen is consumed by combustion, right? Hopefully you remember that from Gen Chem. And so even though this idea of phlogiston, even though it was able to predict and really describe what was going on in burning materials, it wasn't actually true. It actually took a decent amount of time for this misconception to get worked out. And it was actually worked out by Coin Man, Joseph Priestley. Again, he was English. He discovered oxygen, which was originally called dephlogisticated air. Remember, if something could burn, it's because that the air around it didn't have any phlogiston, because once it became saturated with phlogiston, it couldn't burn anymore. And so if there was an absence of phlogiston, it would be able to burn very well. And so, in the presence of this substance, right, we know that combustion requires this. In the presence of this substance, things would burn very, very well, very, very readily. And so we called it dephlogisticated air, right? Because if there's no phlogiston, it's going to burn. Right? So again, it's just an idea. This is the progression of science. People have to make mistakes so they continue to ask better questions, because it's not always true that you ask the right questions, right? You don't know what you don't know. And so it's actually very important to science to make mistakes.